at a session in organic chemistry. We shall proceed from where we stopped last time. We're looking at extraction. Extraction of metals. And basically, we shall look at the metals that are extracted at a level. Remember, we looked at extraction of aluminium. Look at extraction of iron. Look at extraction of zinc. And lastly, look at extraction of copper. The study of extraction of metals is called metallurgy. And you are aware that metals are extracted from what we call ores. So you need to know what is an ore. An ore is a naturally occurring mineral from which a metal is extracted. Remember, all these metals, they have got their ores from which they are extracted. Take, for instance, a review of what we looked at during the extraction of aluminium. The chief ore is bauxite, which is hydrated aluminium with what? Aluminium oxide. So when you are preparing or you are extracting, it undergoes through a series of stages where you know that the first step is for you to roast. Roasting. After roasting the ore, why do you roast? To remove the water of crystallization. But besides that, there is also impurities in the ore. So the impurities in the ore of aluminium, we have silicon ore oxide, we have titanium 4 oxide, we have iron 2 oxide. These are basically the impurities that are present in the ore. So how do we get rid of them? We shall look at that later on. So the first step involves concentrating the ore. So you have to concentrate. Concentration of the ore. And the concentration of the ore involves removing the impurities. So when you are concentrating, before you even concentrate, you have to roast. Roasting, you are removing the water of crystallization. This is a solid, hydrated salt. So you are going to get aluminium oxide and then plus water, 2 molecules of water. So you have removed the water. So it means that the ore itself you are having these impurities. How do you get rid of it? This is the first step called roasting. So you have to go to the concentration stage where you are going to remove what you call the impurities. Remember, we said when you are concentrating with the ore, you react it with concentrated sodium hydroxide solution. Now, this concentrated sodium hydroxide solution is going to react with silicon 4 oxide, which is an impurity. Okay? So the silicon 4 oxide is going to react with sodium hydroxide to form what we call sodium silicate. So this silicon 4 oxide is going to react with sodium hydroxide to give us silicate ions and then plus water. Then also, you realize that aluminium oxide, the one which was obtained as a result of roasting, it is amphoteric. Therefore, it is going to react with sodium hydroxide to form what we call sodium aluminate. Now, the sodium aluminate that is formed is a complex. Okay? It is a complex. So, what do you do? The next step is for you to do what we call seeding. So, during seeding, you react the sodium aluminate with carbon dioxide. You bubble there carbon dioxide to obtain what we call aluminium hydroxide. This is obtained as a precipitate. A white precipitate. So when you obtain the white precipitate, which is aluminium hydroxide, so that step is called seeding. So after seeding, what next? You have to roast or you heat. Okay? So what you are going to do is you heat aluminium hydroxide. This is going to give you aluminium oxide plus water. Okay? So what does it mean is that this is called the alumina. It is aluminium oxide, the one we call alumina. So this is impure. So what do? You are going to electrolyze the aluminium oxide using carbon electrodes. Where of course if you have aluminium oxide, you always add what we call molten chloride to lower the melting point. The melting point of alumina, which is aluminium oxide. So what does it mean? It means that aluminium oxide will break down into aluminium ions and then plus oxide ions. So during the process of electrolysis, the negatively charged ions move to the anode, and the positively charged ions move to the cathode. So what are we interested in is the extraction of aluminium. Therefore, we pick aluminium ions. These are going to move to the cathode where it is discharged. Okay, it undergoes what we call reduction. So we shall have aluminium ions. Okay, this is going to give us what we call aluminium. This is now in form of liquid. Okay, so we balance the equation by adding here 3 electrons. So this is basically what we look at when we are looking at extraction of aluminium. Most importantly, you need to know the ore from which it is extracted, a series of steps, the major impurities that are in the ore, and then you need to know the role of adding molten chloride. We say this is to lower the melting point. The main emphasis of today's session is to look at extraction of zinc. Extraction of zinc. This was just a reminder to recap the other lesson we looked at. So we are going to look at extraction of zinc. Extraction of zinc. So when you're looking at extraction of zinc, we need to know what we call the ore. The ore from which zinc is extracted. The chief ore is what we call zinc blade. Zinc blade. And its chemical formula is written as this. This is zinc sulfide. What we call zinc blade. Okay? There are other ores. There is calamite, which is the same as zinc carbonate. But this is the principal ore from which zinc is extracted. So when you are extracting zinc, it undergoes through a series of stages. Okay? So there are basically 3 stages that we shall look at when you are extracting zinc. The first one is called concentration. The second one is called roasting. Then the third one is called reduction. So there are basically 3 stages that are involved in the extraction of zinc from its ore. The first one is called concentration, the second one is roasting, the third one is reduction. So what is it that is involved in what we call concentration stage? During concentration, this is where you are trying to remove the impurities. You are removing the impurities from the ore. So during concentration, first of all, you get the ore, you crush. Involves crushing of the ore. Okay. Now you crush the ore into powder form. Because we are looking at an ore is a mineral element, so you have to first crush. But as you are looking at the ore, it has impurities. Okay, so there is what we call crushing of the ore. After crushing, you mix it with water containing a frothing agent. A frothing agent such as palm oil. Now they always ask, what is the purpose of the water and what is the purpose of the frothing agent? Now the water wets the impurities in the ore such that they sink at the bottom. If you are using a vessel, like for instance, if it was a tank that you are using to concentrate, the moment you crush, mix it with water containing a frothing agent, it means that the water is going to wet the impurity such that the impurity sinks at the bottom, and then the frothing agent, it gets attached to what we call the ore, such that the ore moves to the surface. When the ore moves to the surface, there is where we blow what we call compressed air. The purpose of the compressed air is to ensure that the froth moves at the surface of the vessel you are using to concentrate. So the purpose of compressed air is to ensure that the froth moves at the surface. Then the next thing is for you to add, after the ore has moved to the surface, you add there what we call, you acidify. Acidify. The purpose of acidify is to break the froth. Okay? To break the froth. Then lastly, you have to skim off. Skimming is like you are removing the froth that was on the surface, because the froth on the surface has got the ore. And therefore, you skim off. After skimming off, you filter. Okay? After filtering, you dry. Okay? You dry the what? You dry now the ore. That is what we are now calling concentration. I say during concentration of the ore, you get the ore and you brush it such that it is converted into powder form, and then you mix it with water containing a frothing agent such as palm oil. The purpose of water is to ensure that it weights the impurity in the ore such that they sink to the bottom. Then the role of the frothing agent, which is the palm oil, is to ensure that it attaches itself. The oil attaches itself to the what? The ore, because oil is less dense. Therefore, when it attaches itself to the ore, it moves to the surface. Then you blow the compressed air to ensure that the froth moves onto to agitate the froth, that it moves to the surface. Then later on, you ensure that you acidify. The role of acidifying is to break the froth. Then later on, you skim off. You remove the upper part such that you filter. After filtering, you obtain the ore, dry it. You dry the ore. So that is what is involved on the concentration stage. Okay? So the ore we are talking about is zinc what? Zinc blende. The next thing is to look at what we call roasting. Roasting is where you get the concentrated ore. The concentrated ore is reacted with oxygen, okay? So when you get the concentrated ore, which is zinc sulfide plus oxygen, you are going to get what we call zinc oxide plus sulfur dioxide what? Sulfur dioxide gas. So this is what we are calling roasting. Okay. So you need to ensure that the equation is balanced. So if we put here 2, we need here a 2. Sulfur is 2, that is means that there is 6, you can put here 3. Okay. So this is what we call roasting. Then during what we call reduction, during the last stage, which is the reduction. Now, reduction process occurs in the blast furnace, where first of all, you ensure that coke, limestone, okay, coke, limestone, and the zinc oxide. These ones are fed into the blast furnace from the top. So what happens is that hot air from the bottom of the furnace reacts with coke to give us what we call carbon dioxide gas. Now the carbon dioxide gas that is formed reacts with excess air. Carbon dioxide gas reacts with excess air, which is oxygen, to give us what we call carbon monoxide. Sorry, this is carbon monoxide gas. Now, why are we getting carbon monoxide? This is a strong reducing agent. It's going to reduce the zinc oxide from the roasting stage. So it means that after doing that, the next step, in fact, this one will not with more oxygen, with more coke to give us carbon monoxide. For the other side. So now the carbon monoxide form is the one that is going to reduce the zinc oxide. So the zinc oxide reacts with carbon monoxide gas to give us zinc plus carbon dioxide. So this is our zinc that we have obtained. Now the zinc obtained is redistilled using lead. Okay, it's redistilled using lead. So we would have obtained our zinc. So basically, these are the 3 steps that are involved during extraction of what? Of zinc from its chief ore, which is zinc blade. So we say there is concentration, roasting, and reduction. So during concentration, you crush the ore into powder to convert it into, and you crush the ore such that you increase the surface area. Therefore, you mix it with water containing a frothing agent such as oil. The purpose of the water is to wet the what? The impurity in the ore. The purpose of palm oil, it is less dense than water. Therefore, the oil gets attached to the oil and moves to the surface of the water. And therefore, you blow there compressed air to ensure that the fluid moves at the surface. You acidify with the acid, adding the acid. The acid can be concentrated sulfuric acid, which breaks down the fluid. Therefore, you later on skim. After skimming, you filter. After filtering, you dry the ore. So I've spent time talking about concentration of the ore because the question can just be specific. Say, describe the process of concentration during extraction of what? Of zinc. There are a series of stages that occur during concentration and the role of each, because they can even ask what is the role of water during concentration, role of the frothing agent. So roasting, you said you react the ore, the concentrated ore with oxygen to give us zinc oxide and sulfur dioxide. That is during roasting. Roasting involves use of oxygen. Then reduction, we need to generate a reducing agent. So meaning this reduction occurs in the blast furnace, where you have to feed in coke, okay, limestone, whereby hot air from the bottom of the furnace reacts with carbon to give us carbon dioxide. The carbon dioxide is reduced by excess coke to give us carbon monoxide, which later on reduces the ore. Not even the ore, but the zinc oxide, which was obtained from the roasting stage to give us zinc, metal, and the carbon dioxide. Yeah, so this is redistilled. You are concentrated using lead. So that is basically the extraction of zinc. I hope this video will be a benefit to you.